Hello students, and welcome to this lesson on logical statements. Our objective today is that we will determine the validity and counterexamples of logic using journal notes and practice problems. So the first thing that we need to do is we need to define a conditional statement. And a conditional statement is simply an if-then statement. And this is written as hypothesis implies conclusion. So we would write this as P implies Q. So P is my hypothesis, or my first statement, and Q is my conclusion, or my second statement. And the way that I would write this, if I was doing this mathematically, is I've got P, and then I've got this arrow, and this arrow means implies, like we were talking about, Q. Or if P, then Q. And this is very similar to a scientific hypothesis, right? It's something that we can test. So some examples might be, if we turn off the water in the shower, then the water will stop pouring. So if P, the water in the shower, turns off, then water will stop pouring. Now, as you may think, this is actually true. So true does imply true when we're looking at a conditional statement. The converse is a special type of conditional statement where you take your initial statement and you reverse it. So you take your conclusion and make it your hypothesis, and you take your hypothesis and make it your conclusion. So instead we would say whatever our Q statement was implies P. So as you can see, we've swapped P and Q. So those statements will now be reversed. Our next statement is the contrapositive. The contrapositive is the negation of the converse. So a negation is like saying not. So, you know, when you're playing around with your brother and you're saying, no, I'm not, you are, that's kind of a negation, right? So you're negating what they're saying simply by saying, no, it's not that way. It's the opposite of that. And a way we might say this is not P implies not Q. Or we can use our negation symbol. So if we have a negation, we can use this symbol here, and that means not or negation. Another way that we might write it is, we could also write it in this way. So both of these symbols could mean a negation. So in this case, we will write not Q implies not P. Our next statement will be called the inverse. And the inverse is simply the negation of our original statement. Or we might say that not P implies not Q. And the way that we would write this is that we would write not, and again, we're using our original statement, so we're using P implies not Q. And then finally, we're going to talk about a biconditional statement. And a biconditional statement is when P implies Q and Q implies P are both true. So the way that this would look then is that we would have P, and what we would do is we just write this arrow that has two arrow ends. So P implies Q, and Q implies P. So we know that P implies Q is our original statement, and we know that Q implies P is our converse. Alright, so phew, that's a lot of vocabulary for us. So we need to see this in action, right? The hard part of this is the fact that there are 4 different things that we're trying to work together with. So let's see what this looks like given a true statement. All right, so we're going to do this as an example, and what I'm going to do is I'm going to use these statements P and Q to show how each of these conditional statements will be built. So P is, you live in Austin, Texas. Q is, you live in Texas. I'm sorry, you live in Austin is P, and Q is you live in Texas. So a conditional statement built from this would be, if you live in Austin, then you live in Texas. So what we're seeing is P implies Q. And so let's evaluate if this is true or not. So if you live in Austin, then you live in Texas. Well, we're going to go ahead and say that that's true. We're going to assume that we're not talking about any other Austins. We're only talking about the Austin that we know is weird and is in Texas. Okay, so we've seen what the conditional statement looks like. So what will the converse look like? Well, remember, we're just going to reverse our hypothesis and our conclusion. So instead of having P implies Q, we'll have Q implies P. So let's write this as a sentence. So we'll say, if you live in Texas, then you live in Austin. So is that true? And we can immediately see that that's going to be false, right? And the easiest way that we can say that this is false is we can give a counterexample. And a counterexample is simply something that exists, right, which is true, that will kind of make our logic seem weird or make our logic false, right? So if you live in Texas, then you live in Austin. Well, I know at least one place that I could live that's in Texas and not Austin, and that's Elgin, Texas. That's a city that's in Texas, but is not in Austin. Therefore, you can live in Texas, but not live in Austin. So that statement, again, is false. So the converse was false, the original statement was true. Now we start to get into the craziness that is the contrapositive. So remember that the contrapositive is the negation of the converse. And it's written as not P implies not Q. And what's really nice is that we can actually just take this idea and we can use the word not to help us figure out the truth of this statement. So we say, if you do not live in Texas, right, because we're still using Q as our hypothesis, then you do not live in Austin. So if you do not live in Texas, then you do not live in Austin. And this is true, because if I lived in Austin, then I would live in Texas. Therefore, the contrapositive is going to be true. All right, and now we can do the inverse. And remember, the inverse was the negation of our original statement. So we'll say not P implies not Q. So let's write out this sentence. So we have, if you do not live in Austin, then you do not live in Texas. So if you do not live in Austin, then you do not live in Texas. Now I know some people who are going to say that this is true because they're very much Austinites, but this is not true, right? If you do not live in Austin, then you do not live in Texas is not true. I could live in Dallas, I could live in Houston, I could live in a number of other places. Texas is a big, big place. And again, we can use that counterexample. So that's exactly how we disprove this. And I'll use Elgin again. And so our inverse then is going to be false. All right, and our last statement is the biconditional. So we have P implies Q and Q implies P must be true. So let's go back and check. So we need to know that the original and the converse need to be true. So let's go back and look at it, and we see that the conditional statement, our original statement, was true, but our converse was false. Therefore, our biconditional statement will also be false. So we're going to say that this was not biconditional. So for your reflection, I want you to think about what is a counterexample, what is a conditional statement, and where is the hypothesis in an if P then Q statement? What letter represents our hypothesis? When you've answered these reflection questions, please let me know so that I can stamp for them. Additionally, once you're done, you will have an assignment that you can get started on. If you have any questions, please let me know, and have a wonderful day. Goodbye.